Given that a and b are constants and that a is greater than b, that's greater than 0. Part A. On separate diagrams, sketch the graph with the equation y equals the modulus of x minus a. So first of all, let me just draw the graph of x minus a. So that's got a y-intercept of minus a, and it's got a gradient of 1. So along 1, up 1. So it's going to cut through here at a. Now let's take the modulus here. So that's going to take all the negative values, all of these values here, and make them positive. So it's now going to go up here like this. The positive values won't be affected at all. New y-intercept is at positive a. So that's my answer for part I. Part II. I now need to draw the graph of y equals the modulus of x minus a minus b. So this is exactly what I've just drawn, but the only difference now is I've got a minus b. So that's going to take my graph that I've just drawn and move it down b squares in the negative y direction. So it's going to be taking this graph and moving it down b. I just need to think carefully, is it going to be something like this, or is it going to be something like this where it's below the x-axis? So basically, is b bigger than a? In which case, if b was bigger than a, it would go below the x-axis. But it's not. We know that b is less than a. We know b is less than a, so therefore we know that it is not going to go beneath the x-axis. It's just going to go a little bit further down. So it's going to look something like this. This coordinate here is going to be the coordinate a minus b. This coordinate here is going to be the coordinate a minus b. The x coordinate was a, it always was a, just the y coordinate has been moved down from being 0 to be minus b. We now just need to think about what these coordinates here are. So this is where the y coordinate is equal to 0. So let's take our graph and make that equal to 0. So we can say that x minus a, the modulus of x minus a, is equal to b. So either x minus a equals b, or minus x minus a equals b. So the first equation just gives me the solution x is equal to a plus b. The second equation gives me the equation where x is going to equal minus b plus a, or a minus b. So these are the values of x where the y coordinate is equal to 0. So this must be the coordinate a minus b, and this must be the coordinate a plus b. So that is my answer for part A. Let's move on to part B now. Hence, or otherwise, find the complete set of values of x for which the modulus of a x minus b is less than a half x, giving you answers in terms of a and b. Well, note that this is what we just drew. So when is that less than a half x? So to help me, let me draw a half x onto the graph that I've just drawn. So this graph I've just drawn here, bring this down here just to distinguish it. let me draw a half x onto this. So this has got a y, this is like redrawing this. It's got a y-intercept of 0 and a gradient of a half. So it's going to cut through here at 0. It's got a gradient of a half, so it's less steep than the blue line. Remember, the blue line has got a gradient of 1. We know the blue line has got a gradient of 1 because of the 1x here. So, looking at my graph, I can see that they are equal to one another here and here. And everywhere between those values, the blue function, so that the modulus of x minus a minus b, is less than the half x. So these are all the x values that I'm trying to find. So if I can find this x value where they're the same and this x value where they're the same, then I can say that as long as x is in between those values, that's the answer. So let's start with this one here, because that's the simpler one, because this was the bit of the graph that was not affected by the modulus. So I can just take my modulus and say x minus a, ignore the modulus completely, minus b is equal to half x. Move the x's all onto one side, so I'm going to subtract x from both, half x from both sides. X minus a half x is a half x. Move the a and the b to the right hand side and times through by 2. So this is that coordinate there. Now let's take this coordinate. Now this was the bit of the graph. This bit of the graph here was the bit of the graph that was reflected by the modulus. So that is the bit of the graph where I'm going to take the bit that's inside the modulus, the x minus a, and that was where it got multiplied by the minus 1. Minus the b equals the half x. So expanding those brackets out, I'm going to add the x to both sides. Just get a bit more room. So add the x to the right hand side. The half x plus x is 3 over 2x. Times both sides by 2. Divide both sides by 3. And so this is my x coordinate of this point. And like I said previously, as long as x is in between those values, so as long as x is bigger than 2a minus 2b over 3 and less than 2a plus 2b, if x is between those two values, then our modulus graph is less than the half x graph.